All right, let's talk about cable management. And I know, hold on before you click away. Because what if I told you that on these massive industrial projects, a super simple choice, just a piece of metal really, could save or cost millions of dollars? Yeah, let's dig into how that's even possible.
So, I just want to put this number out there. 2.3 million yen. I mean, that is a huge number in any project budget, right? And this isn't some guess or a what-if calculation. This is a real, actual saving. So, where did it come from?
Well, here's the story. It happened during this huge petrochemical expansion in Shandong. We're talking 12 kilometers of cable routing, and just one single engineering decision, that's it, led to that massive saving. It wasn't some fancy new tech, it wasn't some complicated financial trick. Nope, it was just changing the type of cable tray they were using.
And that really is the big question here, isn't it? How can the physical shape of a piece of metal, a cable tray, directly lead to millions in savings on something as fundamental as copper wire? Well, the answer's pretty cool. It's all about engineering, a bit of geometry, and even some thermodynamics.
Okay, so let's get right to the heart of it. A cable tray's performance? It's not magic, right? It comes straight from its physical design. And to really get why one is so much better in certain situations, we've got to look at the two main players in the cable management game. So on one hand, you've got the ladder tray, and it looks exactly like it sounds. Two side rails connected by rungs, just like a ladder you'd climb. Then you have the perforated tray. Think of this one more like a solid sheet of metal, but with a bunch of holes punched into it. Now sure, they both hold cables, but how they do it? Totally different story.
Now check out that load action row. This is where it gets interesting. The ladder tray's side rails, which you'll notice are usually thicker, they handle all that weight using something called I-beam bending. It's super efficient. The perforated tray, though, it bends like a flat plate. And a flat plate is just, not as strong. This one little difference in how they take the weight, that's everything.
Engineers have a name for this, the I-beam effect. Think about it. By putting most of the material on the very top and very bottom of the side rail, you get this incredible strength to stop it from bending, but you don't have to add a ton of weight. It's literally the same reason I-beams are used in skyscrapers and massive bridges. It's just pure, smart, structural design.
In this chart, it shows you exactly what that means in the real world. Just look at the difference. A typical perforated tray might handle, 50 kilograms per meter? The ladder tray, we're talking almost triple that, sometimes way up to 200 kilos. This isn't just a little bit better. It's a total game changer for how you design a project. You can have longer gaps between supports, which saves a ton on installation time and materials. Okay, so we've established it. The ladder tray is way stronger, but how does that save millions on copper? Well, it all comes down to one thing, heat. Let me show you. It's simple physics, right? High voltage cables generate a lot of heat. And the ladder tray's design, it's almost all open air between those rungs. That is the perfect way to let all that heat just dissipate. A perforated tray, on the other hand, with its mostly solid bottom, it acts like a blanket. It traps a lot of that heat right where you don't want it.
And this brings us to a really important idea called the ampacity derating factor. It sounds complicated, but it's not. Since the ladder tray is so good at getting rid of heat, engineers only have to knock down the cable's max capacity by a little bit. A factor of 0.85 is pretty typical. But with a perforated tray, all that trapped heat forces them to be way more cautious. The capacity can get slashed way down, sometimes to a factor of just 0.60.
And this is where the millions come from. Better cooling means you can safely run more power through the very same wire. Or, and this is the key, you can use a smaller, much cheaper copper cable to do the same exact job. So you stretch that out over 12 kilometers of high voltage cable and bam, that one decision is how they saved that 2.3 million yuan.
Okay, so the theory is solid, but let's look at the proof. Let's see how this stuff actually works in some of the toughest places you can imagine.
Take Beijing's massive utility tunnels. Down there, every minute counts. By using ladder trays instead of having to pull cables through a closed-off pipe or conduit, the difference was incredible. The access is just so much easier. Crews could swap out a 10-meter section of cable a full 40 minutes faster. For operations, that's a huge, huge win.
All right, now let's jump over to the coast of Oman. Picture it. The air is just thick with salt, and it's super corrosive. It just eats away at metal. So this desalination plant used a high-grade 316L stainless steel ladder tray.
and it worked so well at fighting off rust and corrosion that they cut their maintenance checks from quarterly, 4 times a year, all the way down to just once a year.
And if you want to talk about pure strength, let's look at the Chengdu Metro. We're talking about supporting these super heavy, absolutely critical power and signal cables deep underground. Failure is not an option. They specifically chose a stainless ladder tray because it was certified to handle a mind-boggling 150 kilograms per meter. That's how you guarantee reliability and safety.
All right, so we've looked at the structure, we've looked at the science, and we've seen the real-world proof. So let's just tie this all together. When do you know that a ladder tray isn't just a nice-to-have, but an absolute must-have?
Okay, let's boil it down to a simple checklist. When is the ladder tray absolutely non-negotiable? Number 1, heavy loads. Think Chengdu Metro. 2, long spans between supports, because you need that I-beam strength. 3, you need airflow, those hot, high-voltage cables where ampacity is everything. And finally, 4, ease of access, just like we saw in those Beijing tunnels. If you've got any of these, the advantages are just too huge to pass up. And that really brings us to the final takeaway here. It's so easy to just stick with the standard solution, right? The thing you've always used. But what we've seen today is that digging in a little deeper, understanding the why behind the engineering, that can unlock incredible gains in performance, safety, and especially cost. So it really leaves you with a question to ask on your next project. When is good enough?